Scanning every document for every query is the wrong data structure. An inverted index turns terms into postings lists and answers Boolean searches by intersecting IDs. You'll see how to connect the pieces into a workflow that builds a word lookup and answers both word searches without scanning every document. I'm Professor Pi, teaching AI foundations with simple Python. Search engines and simple text tools hit the same bottleneck. If every query forces you to read every document, response time explodes as the corpus grows. We want query costs to track only the documents that might match, not the entire dataset. An inverted index flips the mapping. Words point to document IDs, so lookups can jump straight to candidates. At its simplest, an inverted index stores a postings list per word, a sorted list of doc IDs where that word appears. To answer an AND query, you intersect two postings lists and keep only IDs present in both. Intersecting two small lists is much cheaper than scanning every document when those lists are small compared to the corpus. We will build a tiny example that shows the cost of a full scan, then construct an inverted index, then implement and/or merges, and finally wrap a simple query planner that orders terms by postings length. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now, let's start by showing the naive approach so the benefit is obvious. This snippet runs the smallest possible Boolean AND search by scanning every document. The viewer-facing problem is that the query work is tied to len docs, even when only one document can match. The code stores a tiny corpus in docs, splits each document into terms, and keeps doc ID values where every term in query appears. This is correct for the toy data, but it repeats work that a search engine should avoid. The snippet also prints how many documents were scanned and which document matched, so you can see the wasted checks. That visible output motivates building an index that answers the same query with much less work. We avoid scanning all documents by building a dictionary from each word to the list of documents that contain it. This example converts the corpus into an inverted index with one postings list per term. Instead of asking every document whether it contains cats, index lets us jump straight to the documents that already contain that term. The default dict list gathers doc ID values. Set doc split prevents adding the same document twice for one term, and sorted IDs gives each postings list a predictable order. That sorted order becomes important in the next step because two sorted lists can be merged efficiently. The visible output shows the term dictionary size and the postings list for cats, so you can compare indexing cost to later query cost. With two sorted postings lists, we can intersect them using a pair of pointers instead of checking every document. This code answers an AND query without scanning docs at all. The key concern is to compare only candidate document IDs from the postings lists, not every document in the corpus. And postings uses I and J as two pointers into sorted lists, appends a document only when both lists contain it, and advances past the smaller ID otherwise. Steps counts actual postings comparisons, so the cost is tied to the list lengths. The snippet prints the shared document and the small number of pointer steps needed to find it, which directly demonstrates why intersecting postings is cheaper than full scanning when postings lists are shorter than the corpus. Users also ask for OR queries that return documents matching any of the terms, not only both. This snippet adds Boolean OR by merging sorted postings lists. OR has a different output rule from AND. A document can appear in either list, but duplicates should still be removed. OR postings looks at the current candidate from each list, chooses the smaller document ID and advances both pointers when the IDs are equal. The out check keeps the final list unique while preserving sorted order. This is the same sorted list advantage. But now, the merge keeps all candidates instead of only shared candidates. The visible output shows the union of cats and dogs postings so you can see the combined candidate set. Now we put the pieces together into a tiny query planner that picks a good order for ANDs and reports work saved versus a full scan. This example turns the pieces into a tiny Boolean search baseline. The main win is that the query starts from postings lists, so work grows with candidate lists instead of the whole corpus. Ordered sorts query terms by postings list length, which is a common practical move for AND queries, because starting with a shorter list can shrink the intermediate result sooner. The loop repeatedly calls AND postings, accumulating total stacks, while full scan checks shows the simple scan style comparison for this toy query. The visible output shows fewer index steps than full scan checks and returns the matching document, demonstrating how the index reduces work in practice. In a real project, you map this toy flow to a dataset like 20 newsgroups or a small Wikipedia dump. Swap doc IDs for integer hashes, and add simple compression or skip pointers before production. It is an inverted index for words, and postings list intersection is the fast way to do Boolean AND. Use it when queries are word-based and you need low latency lookups over many documents. One caveat is that postings lists must be maintained and stored, and very common words can still dominate work unless you use heuristics like stop lists or ordering by list length. A practical next step is to add skip pointers to postings lists and test intersections on a dataset such as the 20 newsgroups collection to measure pointer steps versus naive merging. That change preserves the sorted list algorithm, but reduces pointer operations on long lists. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.